So this is lesson 2, or part 2 of lesson 6.1 for my grade 11 applied math students. And we left off right here, looking at this equation. And this is, actually I shouldn't even call it an equation, it's a set of instructions. It says, the set of all xy values such that y is greater than or equal to negative 2x plus 5, but, this is the important part of this, x and y are integers. They're not rational or real, which means that the solutions can involve decimals or fractions. How do I graph that? Well, first of all, the first couple steps are the same as the way we graph the other ones. We're going to graph this line. Is it going to be solid or dotted? It's going to be solid. How come? Because there's an equals on it. So I'm going to make a solid line for y equals negative 2x plus 5. So remember, let's refresh memory on how that works. Hang on. Yep, there's going to be general form. So this is, we're graphing the line y equals 2x, or sorry, it's negative 2x, isn't it? Negative 2x plus 5. So what does that look like? Just let me check to make sure. Yep, negative 2x plus 5. So remember that 5 is the y-intercept. So that means at the y-intercept of 5, you can put a dot. The negative 2, I think of as a fraction. I think of it as negative 2 over 1. And I think of those two numbers as my rise and my run. Remember that from grade 10 and grade 9? Rise over run. So from this 5, rise negative 2, which means go down 2. And then run positive 1. Which way is positive when you're going back and forth? To the right. So down 2 and over 1 is the next point. And then keep doing that. Go down 2 and over 1. Down 2 and over 1. We've crossed the x-axis now. Now we're into negative numbers for y. Down 2 and over 1. Now technically when I graph a line, I really only need 2 points. So I've got way more points than I need. But by doing more points than I need, I can make a fairly accurate line. Down 2 and over 1. I'm going to keep going until I run out of grid. Down 2 and over 1 there. I'm out of grid. And then I'll go up to the top and I'll go backwards. Think about it. If negative 2 over 1 is the slope, isn't 2 over negative 1 the same number? If you divide negative 2 by positive 1, you get negative 2. If you divide positive 2 by negative 1, you get negative 2. They're the same slope. And I can think of this as up to left 1. Up to left 1. Up to left 1. Run out of grid. And there we go. I'm ready to draw my line now. My line is, and you can use a ruler if you want. I got to use freehand here. Good enough. Let me just keep going here. By positive, negative. So good question. So again, rise of negative 2 means go down. Here, let me erase my Hilbert Hotel story here. Rise of negative 2 means, of course, you're going down 2. A run of positive 1 means you're going right 1. If you were using this version of the fraction, you're going up 2 and left 1. And that's the line you're going to get. Now, once again, I have to figure out whether we want the points on the left side of the line or the right side of the line. So I'm going to test, as I always do, with 0, 0. Does 0, 0 make this a true statement? Now remember, the original statement is up here. It's a greater than or equal to. So 0 for y is greater than or equal to negative 2 times x is 0 plus 5. Is that a true statement, yes or no? Is 0 greater than or equal to 5? No, it's false. So that means 0, 0, yeah, 0 is not greater than or equal to 5. So false, 0, 0 is not in the, I'll just say SS for solution set. Right, so it's not in the solution set. So don't shade the side with 0, 0. Shade the side that doesn't have 0, 0. But problem, we can't actually have all of this space. We only want the grid marks. We only want integers. So what we're supposed to do, and this is going to be kind of a tedious process, I should have given you a smaller grid, is let's take a color, and let's make this nice and big. Let's make a dot. There we go. And let's put dots on all the points we can have. We can have that point, that point, that point, that point. There you go. See, we can have all of the integers, but we can't have the spaces between them. So this is the way they want you to graph it. Actually, I think I've made my dot a little too big. Let's go one size smaller. Oh, I like that. So take some time. Do you have a felt pen or something? Something you can make a big dot with? And make sure that you put the dots that are on the line, but only include the ones that are actual corners of the grid. Do you know what I mean by corners of the grid? I mean, don't include this spot here. Can you see where I'm pointing?
Not the middle of the lines.
Because that's not an integer. Can you see where? Hello? Don't put a dot on that spot. How come? Because it's actually 2.5 for x. Is 2.5 an integer? No. Integers can't have decimals on them. Because 0, 0 was not part of the solution set. So this side with 0, 0 on it doesn't get shaded, and the other side does. You're supposed to. I guess I could have made a smaller diagram. To get the right answer. Oh, look at that. That one's, make a bigger dot when you miss like that. Okay, I'm kind of running out of patience for this too.
Why are we dotting?
I have more patience. Okay, why are we dotting this? Because where does it say we're supposed to dot it? Here. You're only supposed to have integers for your answer. So the actual answers are not the yellow spaces, they're the blue dots. So the zone, including all these blue dots, are my answers. So you're an answer, and you're an answer, and you're an answer, and then we could just keep going. Okay, I think I'm tired of it. So there we go. You get the idea. The answers are the dots. So the solution set is all integers in the shaded zone. And you should probably just make them dots. If you take a look in your textbook, they have some examples where they don't make you graph them. They just give you like, in fact, one of the assignment questions will be like a matching question, where you just have to match the graph to the equation. They'll give you the pictures. So yeah, I won't make you do that very often on the test, if at all. Okay, so there we go. I'll give you a sec to get caught up in your graphing, and then let's move on. Question? That's right. The reason we're dotting, the reason we don't say everything in here is the answer is because the answer can't have fractions and decimals. It's got to be integers. So all of these dots that we made are potential answers. Like this point right here. I didn't graph this one yet. 9, 1 is an answer. How do we know 9, 1's an answer? Well, we know because it's in the zone. What if I didn't have a graph and I had to prove 9, 1's an answer? We'll get to an example like that in a minute. Okay, so I'll let you can go back and color dots yourself. I think we're good. Let's move on to the next example. And somebody just asked this morning. Will they ever be in standard form? Well, there you go. Ta-da. Move to the next page. What do we do with this? I will make you on the test do at least one question like this, 4 marks, without your calculator. You'll have one page where you got to do it without the calculator. And those of you who use the TI calculator, you have to be able to do this anyway. I'll show you what I mean. So I have to graph this thing. Now, I have a couple of tools in my toolbox. There's a bunch of ways I know how to graph. I could graph using a table of values like I was in grade 7. I think I'm going to leave that strategy off the table for now. You know what strategy I'm going to use this one for? I'm going to graph this one. I'm going to graph this one using the x and y intercepts. Because what do I notice about my equation? Why did I choose this method? One way you can approach skills in math is you can think about them like all of the skills you possess in math are your toolbox of math skills. And of course, for any job, you want to use the right tool. What's that old saying that if the only tool in your toolbox is a hammer, you treat every problem like it's a nail. You just take out the screwdriver, the wrench, and start bashing at it, because to you it's just another nail. Why am I picking this tool from my toolbox using x and y intercepts? Well, maybe you'll see as we solve it. How do you solve for x-intercept? The x-intercept happens when y is equal to 0. And I'm just going to use the equals right now because I'm just looking for a point. So this y is a 0. That means 5x equals negative 15. That means x is equal to negative 3. So x is negative 1, negative 2, negative 3. There's my x-intercept. Let's find the y-intercept. The y-intercept happens when x is 0. So 5 times 0 minus 3y is equal to negative 15. So negative 3y is equal to negative, don't lose negatives. Negative 15. So y is equal to 5. So there we go. And there's two, again, what did I tell you? 2 dots is all you ever need to graph. So try to make now a line. Now, what kind of a line do I want? Solid or dashed? Solid, because it's equal to. The numbers on this line count as part of the solution. So let's graph. Try your best to make that straight. I don't know if I did a great job. Oh well, it'll do. And then, which side am I shading? What's the solution region here? Okay, am I going too fast? You're still drawing the line? Okay. You can use a straight edge. Actually, you know what, let me try. I think I have a straight edge here, right? I can draw a line. Let's try drawing a line through these 2 dots. Okay, so let's try drawing a line. Give me a shape. I want a line with 2 arrows on it. Let's try it. Oh, can I move it a bit? Oh, that didn't work. Can I move it? How do I move it? How do I move it? Yeah, I have to turn the pencil off, right? Well, I don't know how to turn the pencil off. How do I turn my pencil into just a... How do I turn my pencil into just a thing? Oh, there we go. I'll just use my finger. That's better. There we go. Oh, I'm pretty happy with that. Ooh, that's professional, that is. Okay, so now, how do we know which side to shade on? Test. Which point do I like testing with? 0, 0. So, does 5 times 0 minus 3 times 0, and this time I'm using this symbol because I got to see if which side it is 5 times 0 minus 3 times 0 less than negative 15? Is 0 less than or equal to negative 15? No, that's a false statement, isn't it? 0 is more than negative 15. What would you rather have in your bank account, $0 or negative $15 million? I think I'd rather have 0, right? I owe the bank a lot of money if my bank account said negative 15 million. So there we go. 0, 0 is not part of the answer, so shade the other side. And this time it didn't say just integers, so I can shade the whole thing. I don't have to worry about those stupid dots. And there we go. And again, you got to try to go right up to the line, but not over it. My coloring skills could be so much better if I went to kindergarten. There we go. There. Oh, I went over the line. But there you go. There's the answer. Everything in that zone would make that a true solution for the inequality. So everything in there is part of the solution set. And I used my x and y intercept way to do it. Is that the only way to do it? No, I'm going to do example 2 a different way. Is that your question?
No.
What's your question?
I'm still a bit confused on how to know which side to shade.
Well, okay. 0, 0 is right here, right?
Yeah.
The middle of the grid. It made the equation false, so it's not part of the answer. Right? This dot here is not part of the solution. So it can't shade this side of the line, because that would include 0, 0. and 0, 0 is not the solution. So it's not this side of the line. By process of reasoning and elimination, it has to be the other side of the line. Question? Yep. That's right. You can't color the false. You color in the true side, yes. All right. I've decided that I'm not going to use the intercept technique for this one. You know why? Well, why did I like it for this one? Why was it easy? What made it easy? What are you thinking? The reason why it's easy is because 5 and 3 are both factors of 15. Right? Look at this one. 2 is a factor of 10. 10 is 2 times 5. But does 4 go into 10 without a decimal? No. So I don't want to do it the intercept way. So this way, this one I'm going to convert to y equals mx plus b. So we have to use our algebra skills a little bit here. We have negative 2y plus 4x is greater than 10. So I'm going to minus 4x from both sides of the equation. Done. Now, what step will isolate my y? I have to divide both sides of the equation by negative 2. And when you do that, when you multiply or divide both sides of an inequality by a negative, what happens? When you multiply or divide both sides of an inequality by a negative, something happens to that inequality. It reverses its direction. So at this step here, I'm dividing both sides by negative 2, but now instead of a greater than, it's now a less than. How does that make sense? I'll get to that in a sec. Let me finish this example, then I'll prove to you that that rule has to exist. It's right here. When you multiply or divide both sides of an inequality by a negative, it reverses direction. So the greater than becomes a less than. You want me to finish this sentence maybe a little more tidy here? Reverses the direction of the inequality. How about that? There, is that a little less vague? Okay, so let's finish off the algebra though. What's negative 4 divided by negative 2? Positive 2. What's 10 divided by negative 2? Are you sure about that? A positive divided by a negative? It's negative 5. There we go. Okay, and this now, again, I know that my y-intercept is negative 5. There it is right there. And I know my slope is 2 over 1. So I can make some points. Rise 2, run 1. And there, that's 2 points. That's really all you need. Can I draw a dotted line with this thing? I don't know. Let's see. Does everybody remember that it has to be a dotted line? How do I know it's a dotted line? There's no equals on here. So the numbers on the line don't count as solution. So let's see. Let's see if I can make a dotted line. No, lines have to be solid according to this. So I'm going to have to just draw my own dotted line. So dotted line, why don't I just keep drawing here? Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, dotted, and this way. There we go. There's my line. When you multiply or divide both sides of an inequality by a negative, the direction of the inequality flips. Oh, are we still struggling with how I got to here? Okay. I figure you're in grade 11, so I'm not really writing out algebra like I would to grade 8 students. But here, watch this. Would it help if I showed you this? Oh boy, that's a big fat pen. Let me make a. Would it help if I drew in a pen so fat you can't read it? Let's try that again. Would it help if I showed minus 4x from both sides like that?
No.
And then would it help if I divided both sides by -2 like that? You want to still show that in your work? Go right ahead. I'm not going to bother. I don't make grade 10s show that either. When I was teaching grade 8 math, I'd make them show those steps. But I'm cool with you not showing that. But if you want to show it again, go ahead. Right? Whatever you do to one side of an equation, you do to the other. That's the only real rule there is in solving equations in algebra. Otherwise, it's just bed mass backwards.
Can I
Yep.
ask how the negative 4x is like replaces the positive?
Well, when you minus 4x from both sides of the equation, what's 4x minus 4x?
Nothing.
Nothing. So that's why it's gone from the left side of the equation. But now on the other side, there's nothing for it to combine with, so it's still right there, -4x.
All I thought about it is just you just transpose 4x to the other
Yep.
side. That's really it.
Somebody used the T word. Somebody said, I just think of it as transposing it. And that's fine. Keep in mind, though, that's not really what algebra is. Algebra is adding, subtracting, multiplying, and dividing, because that's what arithmetic is. Transposing is not really a thing. Yep?
Why did you turn the greater than symbol down?
Because that's what you have to do. Okay, I promised you an explanation as to why this happens. Watch this. Okay, everybody ready? 1 plus 2 is greater than or equal to 3. In this case, it's actually equal to 3, but it's a true statement, right? 3 is equal to 3. What if I subtract a number from both sides? Let's make it even a really negative number. Suppose I subtract 10 from both sides. 1 plus 2 minus 10 is greater than or equal to 3 minus 10. Is that still a true statement? Yes, because this is -7 is equal to -7. Okay, let's make it so that this is in fact actually a greater than. Let's make this one a 4. Is 6 greater than 3? Yes. This is a 4, which actually makes this now 6 minus 10. What's 6 minus 10? -4? Is -4 greater than -7? Yes. What would you rather have in your bank account, -$4 or -7? Who's richer? -4 is more than -7.
Not that much in debt.
Now, if I minus from both sides, it doesn't affect the truth of the inequality. I think we've established that. Let's start with the same inequality, but now let's multiply both sides. Let's multiply both sides by 3. So this was 6. What's 6 times 3? 18. Is 18 greater than 9? So we're still true. What if instead of 3, we multiplied by -3? Is -18 greater than -9? No, the statement's false. The only way for the statement to retain its truthfulness is if when I multiplied by a negative, I flip the inequality. That is the way inequalities work. When you multiply or divide both sides by a negative, you have to flip the sign. Let's do a divide. Let's go back to the way it was before I did all that. That's a true statement, right? 6 is more than 3. What if we divide both sides by 3? Is it still true? Yes, because I have 2 is bigger than 1. True. But what if it was a -3 I divided by? Is -2 bigger than -1? No. The rule is, if I multiply or divide both sides by a negative, I have to flip the sign, or I've lost the truth of my equation. So that's where this rule comes from. You were supposed to be introduced to it for the first time in grade 9. And I'm almost done my question. I'm actually not done it yet. I still haven't decided which side we're shading. Guess what I'm going to try to test with? My go-to. The only time I don't use 0, 0 is if the line happens to go through 0, 0, in which case I got to pick something else. And you can pick anything you want. I like working with 0, 0 because it's super easy. So does -2 times 0, go back to the original equation, by the way. -2 times 0 plus 4 times 0 is more than 10. Is that a true statement? Is 0 more than 10? It is? It's false. False. So 0, 0 is not in the answer. So this side is my answer. So that side's my answer. And there it is. All right, I'll give you a second to shade. And then let's move on to the next example. How about for the next one? You've seen me do a bunch of them now. Which way do you like better for C? Do you like the intercept method, or do you like changing it to y equals mx plus b? Okay, I like intercepts too, but the problem with intercepts is I'm going to have a decimal. Can you see that coming? 9 doesn't divide by 4 without leaving behind a remainder. So I'm going to change this to y equals mx plus b. And I'm going to also tell you, if I want to graph this with my TI calculator, I have to change it to y equals mx plus b. So for this one, please change this to y equals mx plus b form. Okay, so I'll give you a sec. Maybe I'll pause the video. I haven't done attendance yet. I better do that. Okay, so I'll pause the video, give it a try, and then I'll catch up to you in a minute. So people watching this at home, try to graph this one yourself, and then we'll show you how to do it with technology. So I'll be right back. Okay, let me catch up to you guys. So step 1, let's isolate y. So what's happening to y? Y is being times by 3, then I'm minusing this stuff. So I'm going to add this stuff to both sides of the equation, because that's the opposite of minusing. So now I have 4x on this side plus 9. It almost looks like y equals mx plus b, except for this pesky 3. How do we get rid of it? Division is the opposite of multiplying, so we divide. So on that side, I now have 1y, which is what I wanted. That's a positive number, so I don't change the inequality, right? I didn't multiply or divide by a negative. This is a positive, so it's still a less than. And no, I don't want a decimal. Let's just leave this as 4/3. It's easier to think of as a fraction because now I have a rise of 4 and a run of 3. So don't even think of it as 4/3. Think of it as 4 divided by 3 because that's what it is. And then, of course, the y-intercept is 3. So at 3, I put a dot, and then I go up 4 and over 3. Up 1, 2, 3, 4, and over 1, 2, 3. There's my next dot. And then from there, what kind of a line do I want? Dashed, because there's no equals on this. So I'm going to make a dashed line.
How do you even make a dash line so quick?
Because I'm making sound effects. Did you notice that when you make sound effects, you can make better drawings? Just throwing that out there. Okay, so next, I have to decide which side we're shading. Again, my go-to test. I could pick any coordinate point I want, except don't pick one that's on the line. But I could pick anything I want, but if I'm allowed to pick anything I want, why not pick the one that's the easiest to work with? So I'm going to test 0, 0 pretty much every time. So 3 zeros minus 4 zeros is less than 9. Is 0 less than 9? It certainly is. This time 0, 0 is part of the solution. Is in the solution set. That's a true statement. So 0, 0 is in the solution set. So I'm actually going to now shade where 0, 0 is. So I'm shading down this time. Okay. I'll give you a sec to shade, in case you're still catching up to me now. How would I have done this question using the TI calculator? Well, the TI calculator is a little bit finicky. It does not like equations in standard form, so you have to get to here yourself. And then you actually just graph it. Now, let's make sure, the last time we touched this calculator, we were doing stats. So let's go to the calculator, and let's first of all make sure that our stat plots are all off. Yeah, there we go. The stat plots are all off. We good? Stat plots are off. Now, let's make sure that we have basically the same grid that we have here. You know what? This grid of going up by 10, down by 10, left by 10, right by 10, that's pretty much a standard grid. So go to your calculator, and under Zoom, so quit this thing, under Zoom, go to 6 and hit 6, and now you have a standard grid that goes from -10 to +10 in all directions. Now you go to y equals, and you type in the equation we just did. There we go. 4/3, and 4/3 you're going to have to enter as a divide. 4 divided by 3 times x. Your x button's right here, up by the green button, and then plus 3. And then it's going to graph the line. And then you have to tell the calculator which side to shade. And I'll show you how to do that. Now, first of all, we want a dotted line. How do I do that? I don't remember how to do that. Actually, you know what? On this calculator, I'm not sure you can make a dotted line. Let's see. Maybe you can. Over here, can you see where I'm moving the cursor? Move it all the way to the left so it's flashing beside Y1. And then click enter. No, don't want that. Click enter. No, I don't want to shade up. Click enter. There we go. Shade down. Hit graph again, and now it's going to shade underneath. And there we go. That's the best you're going to do with this calculator. If you have the TI-83 plus, like a newer version, or if you have the TI-84, I think you can turn this into a dotted line. I don't think you can on the old 83s. Yeah, you toggle to here and hit enter, and then enter again. No, it doesn't let you do it. It should say whether you should be able to change it. Oh, wait a minute, maybe under math. Go under math. And no. There is a way to do plus or minus, or to do greater thans and less thans, but I don't think we can do it here. So go back to y equals, and I don't remember where that symbol is. Is that under format maybe? Ooh, get out of there. It's not that. Is it under stat plot? Nope, I don't. You know what? I'll look it up and I'll see if there is a way to put a. On the fancier calculators, you can put a greater than or less than, and it'll know whether it wants to make a solid or a dotted line. But right now, this is good enough. There, you can see the graph. All done. Okay, so that's the TI. On Desmos, here's the way Desmos works. For Desmos, you actually don't need to change it to y equals mx plus b. You can literally type it in exactly the way it was. What was the original equation again? It was, go away. It was, what was it again? That's how good my memory is. It was 3y minus 4x is less than 9. So 3y, go away, minus 4x, and for less than, you can see it right there, is less than 9. And as you can see, it just draws it for you. It shades it and everything. And it goes on, yeah, it does go on forever. It is. It's an infinite region of points. And there you have it. So Desmos is way easier than the TI. The TI, you need the algebra skill to change it into y on the left. You know, isolate y. You don't even need that skill when you're using Desmos. So Desmos could be something that somebody who doesn't even have grade 8, 9, 10 algebra skills could graph lines with. Question? Yeah. Yep. Okay, next.
1 over 4, m equals 1 over 4.
All right, let's try this one. So step 1, I'm going to change this to 4y is greater than or equal to positive x plus 12. Why did the x become positive? Because I added it to both sides of the equation, or as some of you like to think, it got transposed to the other side, so it became its opposite. Then I'm going to divide both sides of the equation by 4. Now remember, there is a number in front of this x, it's a 1, right? So this is 1/4 x plus 3. So my y-intercept is 3. And my rise over run is up 1 and over 1, 2, 3, 4. What kind of a line do I want to graph? Solid. So I'm going to try to graph a solid line. So I'm going to use my shapes thing again. That was fun. So I want to make that line And I want it to go through those two things, so I'm going to just drop through both of them. Oh, and then when I lifted my finger, it kind of moved on me. There we go. I like that. That's pretty good. There we go. I'll give you a sec to catch up to me. I got to do a test point. So let's test 0, 0. Is 0, 0 a true statement or a false statement? Is 4 times 0
It's false.
minus 0 greater than or equal to 12?
It's false.
False. So what does that mean? It means 0, 0 is not in the solution set, SS. So shade
Oh my god.
up. Okay, I shaded over the line. So what? There we go. Ta-da!
Wait, so when do we have to like dot all the integers?
When it's an integer question, if it's said after this, x and y are elements of integers in that fancy writing that we did in that previous example. The question was, I keep forgetting that the microphone's not picking up questions. The question was, so when do we have to dot all the integers and do that dot thing? Only when it tells you that this is only an integer solution, and I won't make you draw that very often, if at all. Okay? All right, now let's run through how to do this on the technology one more time. If I was using my TI, I have to change it to this form. So go to my calculator. Let's erase the original equation, just clear, and then it's gone. So I have to type in 1/4 of x plus 3. And then I have to have done my test already, and I have to know that I'm shading up. So then I move the cursor over to what kind of a line it is, which is on the left of the Y1. Once that cursor is flashing, just toggle through the enter option until you get up. There, I'm shading up graph, and there it is. There's my graph. Isn't it pretty? And then the other technology is Desmos. And Desmos, let's just stop that one. So for Desmos, I can go back to the original equation. 4y minus x is greater than or equal to 12. So 4y minus x, and then bring up the menu. I said bring up the menu. Go away, keyboard. That's very annoying. Is greater than or equal to 12. And there it is. Zone shaded, line solid. It's a lot easier than working with the TI calculator. Okay, there we go. Now, one application of this stuff, and there's a few applications we're going to do, one application of this stuff is we can represent real-world situations with these equations. For example, let's read this together. The perimeter of a square is at least 100 meters. So let the perimeter of a square be at least 100 meters. How do you find the perimeter of a square? Well, if I have a square, let's say that perimeter is, hang on, my pen's not working now. My perimeter is going to be y, and the square is going to have a length of x. So there's my square, x and x. And what do we know about perimeter? Perimeter y has to equal 4x. But I know the perimeter is at least 100. Now, which symbol do you think at least is? You have 4 to choose from. Yeah, so perimeter, which is 4x, has to be greater than or equal to 100. So there we go. Those words gave me that inequality. Perimeter has to be at least, which means it could be 100 or 101 or 102 or 10 billion. Right? It can be anything bigger than 100. Let's try the next one. Miss Bednarski bought apples and bananas at Save On Foods. Miss Bednarski bought more than 13 pieces of fruit. So let's let apples be x. You get the you've exactly, you're ahead of me. We'll let bananas. I just misspelled bananas. It's one n and then an a, then an bananas. So there we go, x plus y. So x plus y, and I just typed it wrong, x plus y more than, what do you think? Which symbol are you looking at?
Greater than or equal.
Greater?
I would say just greater than. Is 13 more than 13?
Why wouldn't you just put equal to?
No, so I don't want an equals on this one. More than implies that it can't be 13. Does the logic on that make sense to you?
Why can't you just put an equal sign?
Because it's more than, it's not equals.
Oh, yeah.
That's why we can't use equals. Okay, next.
Oh, more than.
Oh man, I think your grandma wrote this example. Alex is going to play arcades. He's going to play the arcades. You ever notice older people that don't know what they're talking about always pluralize things that shouldn't be plural? What do your sons want for Christmas? Do they want the Pokemons? They always pluralize things when they don't know what it is, right? Play arcades. And then, oh man, and pinball. Isn't pinball one word? This question needs work. I'm embarrassed for this question. Alex is going to play at the arcade. The pinball one-word machine costs $2 a game. And the race car seat, I think race car is one word too, costs $3 a game. So think about this. We will let X equal the pinball game. And we'll let Y equal the race car game. And so think about it. If he plays the pinball machine once, it's $2. Twice, it's $4. 3 times, it's $6. What if he plays X times? 2X. And the race car, if he plays 1 game, it's $3. 2 games would be 6. 3 games would be 9. 4 games would be 12. X games would be? Or sorry, Y games would be, that's right, 3Y. I made a terrible looking X there too. Let me fix that. There we go, that's better. So 2X plus 3Y, that's how much he's spending.
Equals.
Nope.
No, wait.
Greater?
Shouldn't there be an equals, like equals to 20?
Less than or equal to. He has a $20 bill. That's all he's got. Only a $20 bill. That's all he's got in this world to spend at the arcades. So there we go. 2x plus 3y is less than or equal to 20. That's my inequality that represents that situation. And finally, a sports store makes $100 on every pair of downhill skis sold. So I'm going to let x equal the number of downhill skis, and my N and my H look like the same letter. That's no good. And we'll let y equal the number of snowboards. So, what do we know? Well, again, if we sold 1 pair of skis, we got $100. 2 pairs is $200. 3 pairs is $300. X pairs is 100 times X. Every snowboard's 120. Sell 1, it's 120. 2 is 240. 3 is 360. Y is 120 times Y. And what do we know about this? The goal is to make more than. Would he be happy if he made 600? No, he wants to make more than, greater than 600. And there's my inequality that represents the situation. What are the restrictions on my variable? Well, I hate to tell you this because that makes it for the ugly graph, but I would think my restrictions are x, comma, y, both have to be greater than, I guess they could be equal to, 0, right? How are you going to sell a negative number of skis? And could you sell 1.5 snowboards? 3.7 pi? Go in and buy pi snowboards, 3.14. So what is the way that I say that? We just learned it a couple pages ago. X and Y. I don't mind putting commas. You'll notice that the example I gave you, they said it in 2 statements. I don't mind if you put it as 1 statement. X and Y both have to be belonging to, I guess I could even say, it doesn't even have to be integers. I was going to put an I, but now that I think about it, I'm going to say W. What kind of numbers are W? Whole numbers, right. Can't be fractions, can't be decimals. So that's the restrictions on my variables. Feel free to write that in symbols. If the symbols don't work for you, you forget what the symbols mean, you can just write in words, x and y have to be positive and can't be fractions or decimals. That's a good point. You should probably put the, this is a set instruction. You should probably put the set brackets. There you go. There's the restrictions on my variable. I like using the symbols. It saves me writing. It's less writing to write the symbols, if you know what they mean. So there we go. There's the definition of my variables on that one. Okay, so that's one application. One application of this stuff is we can set like real world problems. Another application is, oh wait, we're not done this one yet. Sorry, this one's a full example. Okay, so write the linear system that represents the situation. So the linear system is, let's see, this is the system. X has to be greater than or equal to 0. Y has to be greater than or equal to 0. And then, what was the equation again? 100x plus 120y. Yep. Has to be greater than or equal to 600. Oh, no, not equal. He wanted to make more than. Greater than 600. Determine the solution region. Okay, well, the solution region, let's graph these two lines first. Here's the first line. Oh, I kind of came off the line. I was trying not to. There's the first line, and there's the second line. And if you're greater than 0 for both of these lines, notice that you're only in here. The only answers are in this quadrant. So that took care of those two things. Now let's play with this one. I'm going to rearrange this so that I could use whatever technology I wanted. So I'm going to minus 100x on both sides. Then I'm going to divide both sides of the equation by 120. So that's a negative 100 over 120x, and then minus 600, oh no, that one's plus, sorry, plus 600 over 120. And I would kind of like to simplify those.
That's 1, because 600 divided by 120 is...
So what's 600 divided by 120?
1,
60 divided by 12 is 5. You can use your calculator to help you if you want. This is 5. And how about this simplifies? Knock off the zeros. It's 10 over 12. Divide top and bottom by 2. It's 5 over 6. If you have just a regular scientific calculator that has a fraction button, feel free to use your fraction button to simplify fractions if you're having a hard time with the mental math of it. But there you go. Negative 5, 6x plus 5. So let's graph that. Plus 5. Rise over run is down 5 and over 6. So 600 over 120. Divide both sides by, divide top and bottom by 10. And what's 60 divided by 12? 5 times 12 is 60. So it's 5. So that's how I got the 5. And for 120 over, or for 100 over 120, I again just divided top and bottom by 10 because I noticed they both end in zeros. And then I simplified by dividing top and bottom by 5. Or sorry, by 2. By 2. 5/6. And then it doesn't simplify any more than that. Okay, and now we graph. What kind of a line did we want? Dotted. Oh boy, that's terrible. Let me try that again. Okay, let's try that better. And does everybody get how I got the second point? The first point's my y-intercept, and then I went down 5 and over 6. Okay. Now, which side of the line are we shading? Well, let's test 0, 0. So 0, 0. 0 plus 0 is greater than 600. That looks kind of false to me. 0 is greater than 600 is false. So do not shade 0, 0. And don't forget, stop here. Why stop here? Because we can't have negative numbers. It says so right there. So this is the zone. This is my region of solution. But what kind of answers do they have to be? Yeah, they got to be decimals. Or they can't be decimals, I mean, sorry. They can't be decimals. So we could put dots. Now, again, I'm going to run out of my patience to do this. And notice, oh, don't touch the ones on the line. You know what, that one isn't quite on the line. That one looks like it's on the line. Avoid it. Avoid it. Dot, 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 dot. Why are we doing this again?
No. Why are we?
Because you can't sell point something of a snowboard. I'd like to buy 3.4 snowboards, please.
Why are we not shading the?
And then you get the idea. Keep going. So now,
Why are we not shading?
why are we not shading the whole thing? Because right here, x has to be greater than 0, y has to be greater than 0. Those are boundaries. So that's it. All of the dots for all of the integers are in there. So it now says, determine one possible solution to the limit manager's goal. Any of these dots would work. So for example, I'll just pick an example. How about this dot right here? This is a nice dot. That looks like it's 6, 1. Sell 6 skis and 1 snowboard. How about a point up here someplace? What's that one? That one's 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Oh, 8, 8. 8, 8's a solution. Et cetera, et cetera. How many solutions are there? Yeah, everything, this goes on forever. There's infinite solutions. Now, obviously, there's going to be some sort of limit, right? This store, what are these guys, Amazon? They could have millions of skis and millions of snowboards. There's got to be some sort of limit. But it didn't tell me what the limit is, so that's my solution. It's everything, all of the integers in this yellow zone. All right. One last type of thing we can do with these. And this one we don't have to graph. We just have to do arithmetic. Is this a solution to that? Well, let's check. Remember that this is my x coordinate and this is my y coordinate. So if y is 4 and x is 6, is this a true statement? Does 4 make this a true statement? Negative 18 plus 2. What do you think? Is that a true statement? Yes. True. Therefore, that's true. That's a U. Yes. This point is a solution for that. Let's do the next one.
Wait, that's 4, that's 6, not
If y is 8 and x is negative 1, is this a true statement? Is 8 greater than or equal to 5? True, therefore, yes. We're 2 for 2. I'm going too fast? Okay, I'll slow down a bit. So let's try the next one. If y is negative 5 and x is 2, do I have a true statement? Is negative 5 greater than or equal to negative 4? What do you think of that one? That one's false. Therefore, no. This point would not be in the region if I graph that line, or that region. All right, the next one, you do have to deal with a fraction. Now, we won't take your calculator away for a question like this. So you can use your calculator to help you if you're not great with fractions. But why don't you give those a try? So we'll leave it right there. We'll leave this for you to finish. This will be part of the homework. We'll go over these first thing tomorrow. And I'm also going to assign a little bit of stuff from your textbook, but I'll give you some time tomorrow to work on it. So the textbook assignment, as you can see right here from the blog, that's not my blog. There's the blog. The textbook assignment is, oh, I don't have it on here yet. Hold on. Do I have it yet? There we go. The textbook assignment is page 303, 1 to 5, 9, 10, and 12. And I'm telling you that just for practice, for number 1 and 5, try graphing them yourself with graph paper and don't touch your calculator. For all other questions, 2, 3, 4, 9, 10, 12, you can use either the TI or Desmos, whichever you like better. And just for fun, if anybody found that story I told them Thursday kind of interesting, there's an animated version of it online that's actually really cute. And if you're wondering, well, if you can count every fraction that exists, why can't you count every irrational number that exists? There's a great video that explains that better than I could right there. So there we go. There's today's class. Thanks for watching.